The next one is going to be, let me just see if I can draw it freehand. What kind angle will this be? What kind angle will this be? Okay, so we're doing the topic angles. What kind angle will this be? All right, type it in the. It's a straight line, definitely. It's a straight line. It's 180 degrees. Well done. You guys know the degrees. It's 180 degrees. We've got 180 degrees. That's what that angle will be. Okay. Now, if I draw a line like this and if this whole angle is 180 and this is 80, then what must this be? If it adds up to 180, it's got to be 100, right? Okay. What's another word for right next to an angle? Right next to an angle. What's a word that says you're right next to an angle? And that's adjacent. That's right. How do you spell that? ADJACENT. Adjacent. Adjacent means right next to. So if this guy is standing over here and this guy is standing next to him, he is adjacent to him. Okay, so that's what adjacent angle is. We got adjacent angles, acute angles, obtuse angles. All right. And if I'm not wrong, then what kind of angle is this? A right angle, because I'm not wrong. Did you get it? All right, right angle. Cool. So that's your right angle, which is 90 degrees. 90 degrees. Now I'm going to share with you two important words here. All right. The first one is when you have angles like this, where you had 80 and 100, they add up to 180. If you have a 90-degree angle, exactly the same thing applies. So if I draw a line like this and I say this is 40 degrees and this is 90, that's what the block means, 90. This angle is going to be, if it adds up to 90, 50 degrees. Okay, so that's 50 degrees. Good. Thank you. 50 degrees. There's two special words. All right. The first one, it's a long word, starts with an S, and it talks about angles that add to 180. The second word starts with a C. It's also a long word, and it's angles that add to 90 degrees. Do you know what these words are? So, angles that add to 180 degrees, and angles that add to 90 degrees. Well done, Daniel. Daniel, okay. So we got the word is supplementary angles. Okay, so if you see supplementary angles, angles that add up to 180 degrees. And then you got complementary angles, which add up to, now this is complementary, like when you, it's not a complement, it's more complement. Complementary angles add up to 90 degrees. Okay, so remember, complementary angles add up to 90 degrees, supplementary angles add up to 180 degrees. Now, let's say I have a line like this and I have a point that goes all the way around. What kind of angle is that? It starts with a R. We're going to make a change in the world. We are going to make a revolution. That's it. Revolution. 360 degrees. Thank you. 360 degrees if you start from zero and you work your way all the way to the right. Normally on the Cartesian, or normally on the angle plane, we normally start with zero over here and we go anti-clockwise, stopping at 360 degrees after that, where we get 90 plus 90 is 180, complementary, supplementary angles. No particular name for 270, and then 360 back goes there. So that was that. And now I have angles at a point. I have angles at a point. Let's suppose this angle, and this angle is unknown, but two of them is double the size of the other. And we all know that angles at a point now add up to 360 degrees. It's a revolution. If I go all the way around, it's a revolution. So angles at a point angles at a point add to 360 degrees. What will this angle size, this angle size, and this angle size be? We need a bit of algebra in here. So what we do is we add it up. Say x plus 2x plus 2x is equal to what? What does that add up to? What's 1x plus 2x plus 2x? What's 1 apple plus 2 apples plus 2 apples? How many apples do you have? 5 apples, right? So that means if I've got 5 apples, it's going to equal 360 degrees because that's what that is. What does that mean? That means that 5 times a number equals 360 degrees. How do we find that number? We take 360 degrees and we divide it by 5. Grab your calculators. All right, someone's already shot out the answer there. Well done. If I grab my calculator, I've got 360 degrees divided by 5, and I got 72 degrees. 72 degrees for that. 72 degrees. So now that I got 72 degrees there, 5 times 72 is 360. Okay. I still haven't found all the angles, but I do know this angle is going to equal 72. This one is not 72. What will that be? What's 2x if x is 72? It's 2 times 72. What's 2 times 72? 144. 144, and this is also 144. And if we add those three numbers up, they should add up to 360 degrees. We call this angles around a point. Angles around a point. Okay, let me go to the next shape. All right, the three-sided shape. Everybody know what's a three-sided shape, right? What's this called? Triangle, right? So if this is 10 degrees and this is 130 degrees, what will the missing angle be? What do angles in a triangle, what do angles in a triangle equal?
180 degrees.
180 degrees. Well done. And I can see the answers coming through there. 40 degrees. Because 40 plus 10 is 50. 50 plus 130 is 180. That's if I've got a triangle that looks like this. And in particular, those two sides are equal. And I tell you that this is 40 degrees. How do I find those two angles? If I have, let's make it another number. Let's make it 80 degrees rather, more realistically. What kind of triangle is this, firstly? What is this triangle called? Starts with an I.
Isosceles triangle.
Oh, wow. Well done. Well done. Isosceles triangle. So you got an isosceles triangle, which means that you have one pair of opposite angles equal, one pair of opposite sides equal, and angles in an isosceles also add up to 180 degrees. So these two angles have to add up to 100 because together they have to become 180. That means they each have to be 50 each. Or you can use algebra and write it like this: x plus 80. This is what you would be required to do in a test. Write it neatly like this, and you'll end up with 2x plus 80 equals 180. What you do is then subtract the 80 on the right hand side. When you change sides, change signs in an equation. So minus 80. Then divide both sides by 2. And that gets you 100 over 2. And we know that's 50. So x equals 50. And we do this long write up of an equation. And that's how you would solve an equation. You add all of those up if you have to write your working out in a test. Because normally if you go into a test, they'll give you 1 mark for the answer and they'll want to know how did you get there. So you have to show the equation firstly for 1 mark, and you got to show correct working for 1 mark. So you end up getting 3 marks for this if you do that. If the question says 1 mark in an exam or a test, then they only want the answer. But if the question is 2 or more, then you have to show some kind of working out. All right, some kind of working out for that. So there we go. That's angles in a triangle. Now let's go to the next one. What's the special name for a shape like this? What's the special name for a shape like this? It's got four corners. It's got four sides. Anybody? It starts with the letter Q. Well done, Ishwan. Quad, which stands for four, Latin word for four. Quadrilateral. Lateral, all right. Quadrilaterals, basically made out of four straight lines. Quadrilateral. In a quadrilateral, what do the angles add up to? What do the angles add up to? 360 degrees. Now, did you know you can divide this into two triangles? You can divide it into two triangles, 180 and 180. So two triangles add up to 360. So the whole thing, all of those angles add up to 360 degrees. So you got 360 degrees for all of those, which means that if we have to be given certain values, let's say this is 90, let's say this is 100, let's say this is 120, and I want to find x. Calculate x. If it's 360 in total. 50 degrees. 50 degrees. And that's the answer, right? But if you have to write your work in and you have to work it out, you would go x plus 120 plus 100 plus the block, which is 90, equals 360 degrees. And that would be a mark if you need to show working. And then you'd add that up. That'll come to 220 plus 10 is 310. So 310 plus x equals 360. And this is how you would normally write it with that in mind. You then minus 310 on both sides, 310 on both sides, and you get x equals to 50 degrees. X equals to 50 degrees. Okay. The next thing we have is parallel lines. Okay. Oh, well, before we move on to that, there's something else. What's another word for outside? It starts with the E. What's another word for outside?
Exterior.
Exterior. So this is known as your exterior angle. Exterior angle. And the exterior angle is equal to the sum of the two interior angles. So we say that angle is equal to alpha plus beta. So what is that called? That is called theta. That's called alpha. And that's called beta. If you didn't know, you know now. Not important to remember that as much as to know that it's a value that can take on a size, some angle. So we've got our exterior angle, which means that I can give certain values. I can say, okay, well, if this is 40 and this is 90, then this is 130 because it adds up to 130. Or I can get given that this is 140, and if this is 140, then that will be 100. Or I can get given that this is 2x, this is x, and this is x because it adds up to 2x, right? And let's say I know what this angle is. Let's say this angle is 60 degrees. Can you get me the value of x? $60 degrees, because that makes that 120, right? So that angle is 120, that angle is 60, and that angle is 60, and we have three equal sides. What is the word? What is the name for a triangle where we have all the sides equal?
Equilateral.
Equilateral. Well done. Equilateral. Lateral straight lines equal straight lines. All right, equal straight lines. Quadrilateral, four straight lines. All right. Okay, so we got that. Let's move on to parallel lines now. Got parallel lines. Okay, they're not so parallel. If I look at parallel lines carefully, you can see that I've got a dot here. I've got a top right hand corner left, bottom right. Top right hand corner, top left, bottom right. If I put a cross over here, you can see it's in the same. If you look at each of the dots, let's call this A. Or let's even label it. Let's label it. Let's say I got this A, and this is A 1, 2, 3, 4. And I call this point B. 1, 2, specifically 3, 4. And you can see that angle and that angle correspond to each other. They're in the same top right hand corner. So we say A1 is equal to B1 because they are corresponding angles. They are corresponding angles. They correspond to each other. All right. Then we've got B3 is equal to B1 and A4 is equal to A1. All right. So A4 equals A1 because when you got two angles and they're right opposite each other, when two lines intersect, we call these in particular. So A1's equal to A4 and B1's equal to B3. B1's equal to B3. We call these two angles, I'm going to just write it here at the bottom, vertical angles or vertically opposite angles. Whenever you see the word vertically opposite angles, specifically that's what this is called. Vertically opposite angles is when you have a crossroad and you have an angle at the top, an angle at the bottom, and on the right hand side, it could ever work as well. So these two angles are also vertically opposite. Those two angles are also vertically opposite around that point. So we got vertically opposite angles and we got corresponding angles, all right, which are equal, Okay, let's go to the next two types. The next one, I am taking a drive. Okay, so I'm in my car and I'm taking a drive. Yeah, we in my car. Okay, so there's my car and I'm taking a drive, and suddenly there's a roadblock. They direct me to go this way, and I then continue in this direction. What have I done? I've taken another route. How do you use what's another word for another route? Alternate. That's it. I took an alternate route. Okay, so this alternate route goes around this angle and it goes around that angle. So we're saying that alternate route goes around two alternate angles, and these two angles are equal. Alternate angles are equal. A3 is equal to B2. A3 is equal to B2. And we say these two angles are equal and they alternate. All right, now on the way home, I decide I'm gonna come back, and they open up the road. They open up the road, but they block the other side. So I'm going back home now. And as I go home, oh no, they block the road. So I go down this way and I take another alternate route. And you tell me which two angles are equal now. Can you tell me which two angles are equal now? Type the letter and the number equal to the letter and the number. So they blocked the road. I took an alternate angle. I went around this angle here, A4. All right, and it's equal to B1. Okay, so A4 is equal to B1. Angle A4 equals B1. Alternate angles, and it's a Z shape. If you can see that, it's a Z shape. All right, or it can be like that kind of Z. But it's the angles on the inside, and they opposite each other. It's almost like you got to go over that wall to see it. Let me highlight this now. Let me just highlight this quickly. So if I'm looking at alternate angles, particularly, I know that this angle is equal to that angle. Alternate angles. I also know that this angle over here is equal to this angle over here. Now, what do you also notice about these angles? There's a certain word, they less than 90. Can you see the one less than 90? The one is bigger than 90. What's the two words? This one is obtuse. Can you see that? And this one is obtuse. So the obtuse angles are equal because it's greater than 90, less than 180. But at the same time, on the other side, these two angles are acute. All right, these two angles are acute, like that. So we got obtuse angles on that side, we got acute angles on this side, but they alternate angles. So now if you ever get to a point where you decide, okay, well, let me look at it carefully, and I say, okay, well, I think this angle is equal to that angle, and I say alternate angles. Why will it be wrong? And why? How do you know? You can look at it carefully again and say, okay, well, that's acute, but this one is obtuse, so they can't be equal. What about these two? If I say, okay, well, this angle is equal to this angle is obtuse, this angle is acute, but that angle is definitely equal to that one. Corresponding angles. Can you see that? Corresponding angles, corresponding angles, corresponding angles, and corresponding angles. All right, the first one we did initially was corresponding angles. Okay. All right, so we've got corresponding angles, co-interior angles, alternate angles. Oh, we haven't done one, I said now. Co-interior. Co is another word for together. So co-interior angles is the next one. What's another word for interior?
Inside.
Inside, right? And what's co? Together. So we've got two angles which are together on the inside of the parallel lines. So if I'm standing over here, I can see these two angles, right? They on the inside of the parallel lines. Okay? But they're not equal, right? Definitely not equal. This is obtuse and that's acute. But they add up to something. That's why they're important. What do you think? A3, that's it, Ishwan. A3 plus B1 equals 180 degrees. They are co-interior angles. Together they add up to 180 degrees. All right. So that angle and that angle are co-interior. If I'm standing on this side, which two angles are co-interior? Can you see if I'm looking at the inside of the parallel lines, which two angles are co-interior? B2 and A4. Well done, Harrison. B2. Well done, Ishwan. You got it as well. B2 and A4. Those are co-interior. Co-interior angles are equal. Is that right or wrong? Co-interior angles are equal. Yes or no? No, it's wrong. Co-interior angles are not equal. They add to 180 degrees. But they can be equal if they both 90. Right? If they're both 90, then they are equal. But generally never if it's an angle, it's going to be, the one is going to be 80, the other one will be 100. And if this is 100, then that'll be 80, right? Adds up to 180. So we've got all of these lines. Okay, let's have a look at a quick summary. Let's try and put a few of them down here. All of these different angles that we've just learned. Okay. So let's start with angles in a straight line, right? So we've got angles in a straight line. They add up to 180 degrees. Adjacent angles on a straight line. I'm going to write your ADJ angles on a straight line. And that adds up to 180 degrees. This is also known as supplementary. And then we have the 90-degree angle, which is also known as your right angle. but it's also complementary angles. When you have to add up two angles, they are complementary angles. We said angles in a straight line add up to 180 degrees, and quadrilaterals add up to 360 degrees. We also had the exterior angle is equal to the sum of the interior angle. And we then moved on to another one, angles around a point as well. We had angles around a point add to 360 degrees. From parallel lines, the first one we did was we had some kind of corresponding angles. Corresponding angles. And then, say I draw it this way, we also did co-interior angles. Let's just put that one for now. Co-interior angles. They add up to 180. And we also had the Z shape, which is alternate angles. But you need parallel lines for this. So I'm going to put these arrows in because it's important that they be parallel lines. And this was alternate angles. Co-interior corresponding alternate angles. And at some point we also did that, which is your vertically opposite angles. Vertically opposite angles as well. Okay, so you got all of these ideas in a nutshell. I'm now going to send you a link, and I want you to try these mixed examples. You're going to work from level 1 up to level 5. Okay, and maybe you have seen this before, all right, but I think the numbers change every single time. So I'll just double check if you didn't. Here we go, coming through. Okay, and that's angles.